Hello class and welcome to today's lesson on the sums of infinite series. So we talked about the infinite sequences before, but now we're talking about infinite series. So let's use an example from last time as a kind of refresher. So if you recall from last time, we had 1/2, 1/4, 1/8, 1/16, dot 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 infinitely, saying that the whole sequence was 1/2 raised to the n. Well, let's change that and say now instead of a comma, right, we're going to have addition here. Let me fix that for you. We're going to have addition here. We're going to take the sum of this series, okay? So what happens when we take the sum, right? Let's look at S1, the sum of the series for one term. That's simply going to be 1/2. Well, let's look at S2. That's going to be 1/2 plus 1/4. We get, in this case, 3/4. That's not so bad. And let's keep going. So we have S3 equaling 1/2 plus 1/4 plus 1/8, right? And we get, in this case, that's going to be 1/2 plus 1/4, that's 3/4, and 3/4 plus 1/8, well, actually, that's going to come out to 7/8. And you can see that by just saying that we had 3/4 before, right? Well, we have the same common denominator, that's going to be 2, right? We multiply by 2 to get 6/8 plus 1/8, and you're going to get 7/8. Huh, all right. Let's do another one. Why not? So let's do the fourth one. And I don't know if you're noticing yet, there's something very peculiar going on. 1/16. Well, you might have a hunch what we get here. But in this case, we have 7/8, right? Plus 1/16. I'm just taking my preceding sum and just bringing it right here because that's what I know this chunk here is. Well, if I do that, I'm going to get, in this case, I have to remember, multiply by 2 to get the same common denominator. This is going to be 14, 16 plus 1/16. You're going to get 15/16 here. You see that? Huh. Well, what's really noticeable is that we're seeing a pattern of our sums. And now, again, if we want to find a sums for a finite series, right, we would do S of n is equal to the first term. Remember, this is geometric because it's multiplied by 1/2. 1 minus the ratio raised to the n over 1 minus r, the ratio. So the first term is going to be 1/2. Well, we're going to have 1 minus 1/2 raised to the n over 1 minus 1/2. Well, what does that equal? Well, we can cancel all this out, and this is actually going to simply come out to 1 minus 1/2 raised to the n. Now, I'm going to urge you, if this jump from here to here didn't make sense, please take the moment to look through it and try it out. I guarantee it does, but sometimes it helps if you actually do it yourself. Okay, so I hope you took that moment if you needed it. But there's something really important here. I'm gonna definitely look at this now and say that I'm gonna pull this part out here, and put it up to the side, and that the sum n is equal to 1 minus 1/2 raised to the n. What did we remember from last time? As we're going infinitely, right, towards positive infinity, what happens to that 1/2 raised to the n? Well, it comes 0. So if this is becoming 0 here, what's 1 minus 0? 1. So we're getting that, and I know this, I'm probably getting super excited here, that 1, as you're taking this whole chunk here, this whole thing, this term plus this term plus this term plus this term, as you're getting all these sums together, what are you approaching? 1. And you can actually see that. Look at that. We're getting the numerator getting close to the denominator. The numerator close to the denominator, but it never reaches it. But it's so close. So as the limit of that, right, the limit as x approaches infinity for this series, well, that's going to be equal to 1. So that's something really important to mention. And we have 2 new terms from this. I mentioned one, I think, in the last video, but I want to reiterate them now, is if as you're taking a limit and you're taking a series and it's getting to a specific value, we call that obtaining a specific value from a limit. Well, from a limit is, my apologies, is going to be converging or converges, is converging, yeah, converging in this case. I can spell. And if you obtain a value that is not exact, like infinity or negative infinity, obtaining positive or negative infinity is considered divergent. So you're saying the series is divergent. Now, that does not mean the limit does not exist. The limit is infinity or negative infinity. The limit does not exist in another case where basically you can't find the limit, which is completely different. All right? So let's go over a few more definitions. So a more formal definition is to state if your ratio, the absolute value of it, is less than 1. So that is the magnitude is less than 1, the infinite geometric series of, let's say, term 1 plus term 1 times this ratio once, this ratio squared twice, so on and so forth. That means it's going to converge with the sum being this formula here. So we better write this down. S is equal to the first term over 1 minus r. And that's what we had in the last one. Remember where you had the 1 minus or 1/2, that ratio was basically making that top part go to 0. Okay? So the sum is equal to t1, the first term, divided by 1 minus r. But the thing is, if your ratio is greater than or equal to 1, right, and that's the absolute value of it, and the first term is not equal to 0, then the series diverges, and that means your sum keeps increasing in either the positive or negative direction. All right, let's test this out. Okay, for this one we have the series 9 minus 6 plus 4 minus yada. Find the sum. So let's try it out and then give it a moment and remember to apply what we had just learned. Okay, so let's go through it. We have our first term. We have to write that out. That's probably really easy to put, that the first term is equal to 9. And let's see what happens. Remember, this is infinite geometric, so I'm looking for a common ratio. So I'm saying that we have negative 6 divided by 9. What do we get? Well, we get negative 2/3. And that is going to be consistent. Now let's just check it, because why not? Maybe my math is terrible. And yes, it is negative 2/3. So our ratio is negative 2/3. All right. So let's apply that. And remember, our application here is going to be the sum is equal to your first term, 9 divided by 1 minus negative 2/3. So this is going to be 9 plus 1 plus 2/3. That's going to be, in this case, I think 5/3. Right? I believe I could do it. 5/3. And we have this multiplying. Change flip. This is going to be 27/5. And that is your sum for this infinite geometric series. So I would say that's pretty simple. Once you get the hang of it and understand where this whole thing's coming from, it truly helps. All right, let's do another one. So for this one, this might be a little bit more tricky. For what values of x does the following infinite series converge? You're looking for converge. Hint, hint, what does that mean? Look up your definition. Okay, and this is the series 1 plus x minus 2 plus x minus 2 squared plus x minus 2 cubed. All right, something might be afoot in terms of what we want to see here. All right, take it a moment to see what you can do. So first off, I'm just going to mention you have a common ratio here. The common ratio is going to be simply x minus 2, right? We can see that it's happening. From 1 to this, you're going to have to have multiply by x minus 2, and from here to here it's just squared, so another x minus 2. So that's the common ratio. But your T1, that's also important, that's going to be just equal to 1. Now, I wrote that out, but is it necessarily helpful? I would say no, it's not. Because remember, what is the key definition here? It's saying when does it converge? And when does the series converge? It happens very specifically in this scenario when the ratio is less than 1. It happens when the ratio is less than 1. So if this is the ratio, let's plug that in. Plug it in. X minus 2 is your ratio. So we were trying to see when does that happen, right? When does that occur? So in this case, we look at it as x minus 2 less than 1. That's going to be x is less than 3. And we look at the other perspective to say that if everything is negated, right, 1, that's going to be minus 3 to the other side. So minus 2 to the other side, you're going to get negative 1, right? And then we negate both, and we flip the sign. X is greater than 1. So we have these bounds to say that it is from 1 less than x less than 3. And that is your interval for this convergence. And that's your answer. Alrighty, I hope this lesson was helpful for you and that you were able to get some understanding of this idea that a series can converge or diverge. So, I'm glad you can join me on this lesson, and it was a pleasure being with you all today. Take care, and I'll see you all next time.